Welcome everybody to my channel AG Maths, the way of life. In my previous video, I have discussed about the functions and the domain and range in further more details. I talked about the testing of a function, how we test a function is there or not. All relations are not function, and if we draw the graphs with a vertical line test, we can find out whether a graph is of a function or not a function. That is, if it intersects in one point, the vertical line, with the graph curve, it is called a function, and if it doesn't, if it makes two or three or more intersections, it is not a function. So with that continuation, I'll further talk today about types of functions. Now, how many types of functions are there? We'll talk about that. Functions are mainly two types. Mainly, the functions are two types. One is called 1, 1. The other name is injective. Other is called many one, and it is also called surjective. These are the names of two main divisions of function. One is called 1, 1, which is also named as injective. Second is called many one. Other name is surjective. Now, functions are defined from domain to range. Suppose this function is R to R. R to R means it is real number to real number. And we take an example of this real number to real number. Suppose this is the domain called X and this is the range called Y. Let my function be a fx, which is equal to 3x plus 1. I take an example of a function as 3x plus 1. Now, we know we should have two sets, and the relation between them will be a function of 1, 1 or injective type if for each value of the domain, for individual values of domain, we have individual values of the range. So how we get it? Suppose real number, I am writing 1, I write minus 1, I write 2. So if I put this value in the function, if I put x is equal to 1 here, we get 3 plus 1 is 4. So 1 can be related to 4. If I put minus 1 here, so minus 3 plus 1 is minus 2. So this is related like this. If I put x is equal to 2, then we get 6 plus 1 is 7. So this is 7. If these two sets have got only this limited numbers of some real number here, real numbers can be positive, negative, even 0, and we have again positive, negative, even 0 in the range type, range set, then it is called a 1, 1 function, or this is also called single image. Single image. What is the image here? 4 is the image of 1, minus 2 is the image of minus 1, 7 is the image of 2. Now let's go to find out many one. In many one, again we take the function, suppose it is having domain as real number and is related to the range as real number. Real to real number is the function. And suppose the example is function is taken as x of square. If it is x square, then again we will have two sets here. Let me draw it properly. Let one set be here. So it is plus 1, minus 1, plus 2, minus 2. If we have these values in the domain, is the x values, and the function goes x to y, then what we get, if I put x1 here, then what is the fx value we get? It's again 1. So this is related like this, fx is equal to x square. Second element, if I put x is equal to minus 1, again I get 1. So minus 1 and 1 both are having output as 1. Input was 1, minus 1, and output came as positive 1. So it is multi numbers of element which is giving single image. Similarly, you look at 2. If I put 2, then square of 2 is 4. So we get a value 4. And when I put x is equal to minus 2, there also I get a positive 4. So both are again related to single image. So this is called many one, because more than one element giving single image. More than one gives single image. This is how we understand what is a many one function. It is also called surjective function. Now let us take algebraic meaning. What is the algebraic meaning of 1, 1? Algebraically, how we work out? Algebraically, this 1, 1 function is defined as, if I put f as fx1 and x is also x2, and if I say fx1 is equal to fx2, and the result I get, and if I get, then x1 becomes equal to x2 only, then this type of relationship will be called a 1, 1 function. Let us put x1, x2 in this function. So what will happen? I write fx1, which is equal to 3 times x1 plus 1, and fx2 is 3 times x2 plus 1. Now I have to equate. Given condition is that algebraically, if this is and this are equal, then the result should come as x1 and x2. We verify that. If it comes, then it will be called a 1, 1 function. So let us see. If I say 3x1 plus 1 is equal to 3x2 plus 1, then we can cancel this, and 3 can also be get cancelled. So ultimately what I get is x1 is equal to x2. So this proves that 1, 1 satisfies this algebraic condition. So in algebraical definition, we can say 1, 1 function is such a function, if I put x is equal to x1 and x is equal to x2, then the value of x1 and x2 should be equal. Then only we say that this relation or this function is a 1, 1 function. Practically what it meaning, if I am putting 1 and if I am putting 2 and I get the same value, then we get the x1 is also equal to x2. It will not be 1 and 2. As in the graph you must have seen that 2 points coincide, x values will coincide if y value is same. So this is what is the algebraic meaning of 1, 1 function. Now let us talk about the other one. Algebraically, what is the concept for many one? In many one, we know fx1 is equal to fx2. If I put fx1 is equal to fx2, then what happens? My function is this. So x1 is equal to x2 means x1 square is equal to x2 square. Right? From here, we won't get only x1 is equal to x2. We'll get something else. But here we got only x1 is equal to x2. So here we can write x1 square minus x2 square is equal to 0. Now it is a square minus b square form. So we write x1 plus x2 multiplied with x1 minus x2 is equal to 0, which gives me that x1 is equal to minus x2 and x1 is equal to plus x2. This is very clear here. If x1 is called 1, then 1 is also equal to minus 1 because we get the same image for if x1 is equal to fx2, and if we call it x1 and x2 as 2 and minus 2, then again we get 4. So this also proves that it is same. Now they have some subdivisions. What are the subdivisions of this main types of function? 1, 1 and many 1 will have two more divisions among themselves individually. Individually, what I say is 1, 1 is having again two parts. First part is called on to, and this is called into. This will also have two subdivisions, which is on to and into. Right. Now, what is the meaning of on to and into? On to means codomain is equal to domain. Here, codomain will be exactly equal to the range. This we have already discussed what is range, what is domain, what is codomain in my previous videos. If you have the clear idea, fine. Otherwise, you can revert back to my previous videos and get the clear idea of what is codomain and range. Now, to explain it further, if we have two sets and we have three elements here and we have again three elements here, and each element are connected like this. None of the elements in the codomain are unconnected or free. There is no shortage, no excess of any element in the codomain, or we mean to say that this is the codomain which is called Y and also called fx. So Y and fx are equal, then codomain and range are same. It is on 2 and it is 1 1 on 2. That is what is the meaning of onto. Now if I come to into will have little difference from here. Suppose the same x elements are three elements here, but in the codomain we have some one or two extra. Instead of three, we have say five. Five elements are here, and we have connections only like this. Two elements are still free in the codomain, or we say the codomain has got more value than the range. Range are what is connected with the domain. These values are called the range. Suppose it is R1, this is R2, and this is R3, and this is my X1, X2, and X3. So they have got the range values, but this is extra, which is coming in the codomain. Then we say it is into function. 1 1 into. Now we don't have any uh, theory to explain or prove that how two given functions or one function is a 1 1 into. So what we will do, we go in the negative way by proving that this function into function will not be a 1 1 onto. So when we do not get onto relationship, we say it is into. So the negative way of approaching the onto will be proving that it is into, 1 1 into. Similarly, when we look into the many one onto, we will have again two sets, and we may have three elements. These two elements are connected to one because this gives me many one, and this is connected to one element. So it is called onto. No extra element in the codomain or the range. There is no extra, no extra element unconnected. If there is nothing unconnected in the codomain, we say it is on 2. Likewise here. And in into what will happen? We will have some extra element which is unconnected. So again we have 1, 2 and 3 here. If we connect two elements like this, one element is connected and we may have two extra. So there are some extra elements unconnected. It is called into. So this defines the types of function which we have been talking. Now, before I give you one riddle for today, I'll request you, if you like this video, please click on the like button, the icon, and also subscribe in order to get the intimations for my upcoming videos in the same topic. And if you have any query or doubts, please reach me through the email which I have already posted in my videos, and you can also put a comment in the comment box in the same video. I'll get back to you or through this video so that your queries are answered to my best of knowledge. I have got one small riddle. The riddle is the event has taken place in the movie called Die Hard. Right? A bomb is about to go off but can be diffused if someone places a weight of exactly 4 liter. A weight of 4 liter of water on top of a scale. Suppose we have a scale here and a bomb is put here. This is a bomb. It will get exploded in some time. And there is a scale on which one should put a weight of 4 liters of water. If you put a weight of 4 liter of water, the bomb will get diffused. And there is a time limit. The bomb is already put to a time bomb. And we have access to a jar. A jar is there, a big one and a small one. This is 5 liter capacity. I write L, and this is 3 liter capacity. These are the two jars we have. Enough an amount of water is available. Water is no shortage. Enough water is flowing there, and we have access to only 5 liter and 3 liter, but ungraduated. These are ungraduated. There is no graduation. And tell me how you will quickly measure 4 liter exactly to put on this so that the bomb gets diffused. Otherwise, everybody dies. So that is what is the riddle for today. I will give you the answer in my subsequent video. Thank you very much for your valuable time and watching. Please follow my videos. Thank you very much.